And here we are live from Colorado. It is parametric equations. Woo, woo, woo. Okay. Discuss the curve defined by the parametric equation. So what parametric equations are, they're parametric equation requires a parameter, a variable t, usually, which is usually time, okay? And when you plug in that time, you have a separate equation for x and you have a separate equation for y. And you can generate all kinds of interesting curves using parametric equations. Like this one's not that interesting, but if you put like a 2 sine x in here or something, so y is doing sine stuff and x is doing squared stuff, so it's going to give you some funky little function. You can experiment with different types of parametric equations, but mostly they're used for when you have things where time is a variable, like in projectile motion, where you're throwing an object into the air, or you have trains trying to catch each other or something like that. But that's when you use parametric equations. All right, so to graph a parametric equation like this, discuss the curve. That means graph it and tell what it looks like. You just plug in values into the x equation and then into the y equation, and then you graph those 2 points. So we're going to do that. So when I plug -2 in for x into this equation, what do I get? 12. Very good. When I plug -1 into this equation, what do I get? 3. When I plug 0 into that equation, what do I get? 0, 3 again, and 12. Are there any questions over where I got that from? Is that easy? Okay. Now when I take -2 and I plug it into the y equation, I get -4. Okay. And then I get 2 times it. Oh, I know that. That's -2, right? When I plug in 0 in here, I get 0. And then when I plug 1 in here, I get 2. And I plug 2 in here, I get 4. Okay? And then just how you would do on a normal x and y axis. Now, since there are no negative x values here, I'm just going to make my graph, all the x is positive. So I'm going to draw my x-axis right down here. I wanted to make it line up there. And my y-axis right down here. Okay? And now I'm going to plot these points as I normally would. I'm going to change colors though. And so I'm going to plot the point 12, -4, which is, this is 12 out to here, and then down 1, 2, 3, 4. Okay? And that's the first point that's generated by this parametric equation. Then I plug in 3, -2. Okay? So 3, -2 means you go out 3 and down 2, there's that. And 0, 0, you know where that is. And I'm just plotting in the xy plane. 3, 2 is up here. And 12, 4 is here, right? And if I connect those, what do I get? I get, if I keep it smooth and I plot it in some points in between, I'm going to try. I'm not a very good parabola drawer, but you do get a parabola, okay? Sideways parabola. Looks more like a whale or a fish or something. What? What? No, if you look from the top, look, if you look from the top, it looks like Flipper, right? Okay, so if I wanted to graph that in my graphing calculator, which you're going to want to do, okay, eventually, is watch how you can do this. Up, 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 up. So, getting my graphing calculator, is it still there? No, it's not. Let me show you. So I'm going to go view Oh, I did it already. Always in front. And I'm going to go, I'm going to close this, I think. So if I wanted to graph that on my graphing calculator, the way I can do that is go make sure in mode that you are in parametric, okay? PAR, right there. And then, what for now, sequential it wouldn't matter in this case, but we want to be on simultaneous because eventually we're going to be graphing two parametric equations at the same time, okay? Then, when I set up my window on this one, window, I set, since my lowest t was -2 and my biggest t was +2, I just set that as my t min, t max. And then the t step, I just tried to set that at 0.1, but you could set it should be something like 0.1 or something like that. That just tells you which points, you're going to plug in points like every 0.2 in this case or so. I don't know why that came out to be. Let me change that to 0.1. Do I have to delete all this stuff? How about if I do clear, and I go 0.1, okay? And then the y max, or my x max, since I knew my lowest x was 0, my biggest x was 12, I set that to 15. My y min, since I knew my lowest y was -4 and my biggest y was +4, I set that from -5 to 5. And then when you go into your y equals, okay, you get something that looks like this. You have an x1 and a y1. So this is your equation. This is what x is doing. And this is what y is doing, okay? And then if you hit graph, okay, you get this curve. And notice that it started down here, right? It started down here and it started generating when t is -2 and then going through and going that way. If you want to slow it down, you could change your steps. So if you want to see it go slow, you could change this to like 0.01. 0.01. Let's see what happens then. Then you can see it start here. See how it goes a little bit slower? Okay? And then it goes boom, boom. And it generates that curve. Isn't that cool? Isn't that neat? So you always wondered what that PAR button on your calculator did, didn't you? Okay. You did it last year? Oh, sorry. Oh well, that's okay. Oh! What happened there? Let's go back. So now, but wait, if I click on this, then it goes away. Oh, hit the wheel. I want to get my arrow. I want to drag this thing. What's going on? There we go. So now, so this just tells you various things about the parametric equation. So this thing here tells you how to change this into a rectangular equation. So to do that, what you want to do is solve for, you want to get t by itself. The easiest equation here to get t by itself is what? Divide by 2, okay? Why? Because I said so. That's why. What? Oh, why?
He was trying to make a joke.
Because you're going to try to get into a rectangular equation. That means all in terms of x's and y's. So if I solve this equation for t, right, I get t equals y over 2, right? And then I'm going to take that and I'm going to plug it in over here into here, right? And that gives me x equals 3 times y over 2 squared, which is 3 times y squared over 4, which is exactly the same as writing 3/4 y squared equals x. What shape does this make? A sideways parabola, right? With its vertex at 0, 0, opening to the right, right? Which you did on that test, right? Get that? Or you could write it as y squared equals 4/3 x, which would be better, but that's it. Are we good with that? Okay, let's move on then. So, how do you do this? I know. Good thing. Find the rectangular arcade. So this one's kind of weird because you have to apply kind of a trick. Okay? It says, find, let's change colors, I don't like red. This blue is very nice. You divide both sides by A. Here. That's not blue. What do you call that? A teal? More of a teal? No, that's teal. I think it's teal. That's teal. So what you get, this goes away, and now I get x over a equals cosine t, right? And y over a equals sine t. And why would I want to do that? Because I know that sine of t squared plus cosine of t squared equals, you remember this from last semester? What's 1, right? And the reason I did that, because now I know that x, you really have to know how to do this because this is kind of a trick. Since sine of t squared is, whoops, not x, but y, right? Sine, that's y over a squared. And cosine is x over a, and I square that. That's equal to 1. And then I square that and multiply through by a squared. I get x squared plus, or excuse me, y squared plus x squared equals 1. Or equals a, I'm sorry. A. So you guys see where a squared. Alright. Y squared, right, I square this, y squared over a squared plus x squared over a squared equals 1. And then I multiply through by a squared and I get this. What's this the equation of? It's a circle with a radius of a. Okay? So what's kind of cool, if I wanted to graph this in parametric mode, let's just show you. Okay?
No.
Yes? You don't want me to show you? Yeah, you do, because you're going to have a homework problem kind of like this. So, how do I get out of here? Watch. Say I want to graph like, oh, it's right here. So, if I go in here, and I go y equals like 3 cosine theta t, and y equals 3 sine t. Where's t? T. And make sure that you're in mode radian. And also you're going to have to change your window, okay? Because I know that this is going to have a radius of 3, right? So this I'm going to change also to 0 to 2 pi. Because what I want to do,
Change it to 0.
0 to 2, is that pi? Where's pi? Right here? Pi. Here? 2 pi. I'm going to change this to 0, sorry. I'm going to change that to 0. I'm going to change my window so I can see my whole circle. So x min I'm going to change to like -5. -5. And x max I'm going to change to +5. And then I'm going to go from -5 to 5 down here. And now hopefully if I hit graph, I should get a circle. Look at that go. And since I graphed it from 0 to 2 pi, it should take me around that circle one time. And the reason the circle doesn't look like a circle is because that window is not a rectangular window, right? If I did zoom square, it would make it a rectangular window. It would make it an exact circle.
Let's see it.
Okay? Where's the zoom button? Is this zoom?
Yes.
Zoom square. It will make it a nice circle, I hope. And if you want to make that faster or slower, you have to change the period, and we'll talk about that probably not tomorrow. But there it goes. Look at that perfect circle. Isn't that cool? Okay, so it's graphing x and y, and you're plugging in t as you go, and it stops right there, and you get something that looks like that. Neat. Oh, okay. So then, one of the most useful things about parametric equations is for this type of problem. Okay, if you are a gunner in the army and you want to get the bad guys, okay, you can use this set of parametric equations, and these are formulas out of physics. Okay, and this one gives you, so when you shoot an object, right, it starts off at an angle. So say you're shooting a cannonball, or in this case a golf ball. As we learned in the last chapter, you can break it into a horizontal component and a vertical component, right? So this thing here gives you the horizontal component of that vector, and this thing here gives you the vertical component, the y component. And x and y are doing two separate things. So suppose that Jim, we should say Tiger Woods, Jim hit a golf ball, initial velocity of 150 feet at an angle of 30 degrees to the horizontal. Find parametric equations that describe the position as a ball as a function of time. So you have that x equals v sub 0, that's this, 150 feet per second times the cosine of 30, right? So in this case, times t, right? So Tiger is launching his golf ball at 30-degree angle on that one, okay? What? Then y equals negative 1/2. What's g? In meters per second, but we're in feet.
16.
Negative 16 is divided by 2, so it's actually 32. The acceleration due to gravity is 32 feet per second. But what happens with that formula is it gets divided by 1/2. Okay? So you have negative 1/2 times 32 feet per second, that's gravity, t squared, plus v sub 0, which again is 150, times the sine of 30 degrees, okay, plus h sub 0. H sub 0 is the initial height. Well, since in this case he's hitting the golf ball off the ground, the initial height, this is equal to 0, okay? But if you were like hitting off a tabletop or something, then initial height would be something different. So really what's happening is right at the very beginning it looks like this, but it's going up and then gravity is pulling it back down to the ground, right? And you're going to end up having a parabola that kind of looks like that. And you could plug in both of those equations.
You forgot your t after sign.
Whoops, thank you. I forgot a t over here. Okay? Now simplifying these, I'm going to grab this so I can simplify this a little bit. Okay? Simplifying these two things, I want to finish this problem. So if I simplify this, I get that, let's change colors. Can I change colors? Maybe. Light changes to this color. So x is 150 cosine 30. Anyone remember what cosine 30 is? Please. Root of 3 over 2 t, which is the same as 75 root of 3t. That's x equals, okay? And y equals negative 16t squared. Sine of 30 is 1/2 plus 75t. And since this is equal to 0, you could just forget about that. So the first question asks you what? What does it ask you? Or the second question? How long is the golf ball in the air? When the golf ball lands, what will its height be? 0. So you set the y component equal to 0, not the x component. So to answer that first question, you set this equal to 0. And to solve that, you can do some algebra here. Factor out a, what should I factor out? A t times negative 16t plus 75 equals 0. Okay? And so then you could have two answers, either t equals 0, which makes sense because the ball has a height of 0 when it starts off, or 16t equals 75, which gives you t equals 4 point something. 4 point about 6.8. Okay? About. So that's how long the ball is in the air. The next question asks you, how high does the ball go? Does it? Or so to figure out how high the ball goes, remember this makes a parabola, right? So it's going to start off at some height, and then at what point in time is it going to be right here? Half the time. Thank you. So when it's at this height, this t is going to be half of this, which is approximately 2.34. And then if I take that point and plug it into this equation, okay, I get out how high the ball goes. Okay, you're basically finding the vertex of that parabola. And so y of 2.34 gives you like 68 or 89? What, anyone do that? I got it up here. It gives you about 87.9 feet. Okay? So about 87.9 feet. Okay? Quick, I'm not done yet. The next question says, how far did the ball travel? How would I figure out how far the ball traveled? What t do I put in here? Very good. Because it was in the air for 4.68 seconds from the time it went from here to here. To figure out how far it traveled in the x direction, I plug in 4.68 into here, and I guess that x is about equal to...
Please pardon the interruption.
Oh, hey.
Please listen to the following announcement regarding TCAP this week and next week. Students in grades 9 and 10 will be taking TCAP testing on Tuesday and Wednesday during the next 2 weeks. Your rooms will be posted outside.
Little part of the problem. So then, if I plug in 4.68, I get that x is approximately equal to 609 feet, approximately 609 feet that he went in the air. Okay? And that's it.